All right, welcome everyone. I've got a lot of content, so I'm going to go through it relatively quickly. I will share the slides afterwards, so don't worry if I'm skipping ahead, because the point is for me to talk to you, not for you to read from slides. So, I was originally going to call this debunking zero trust in ICS, but the vendors don't necessarily like it when I say that, so I don't know why I just did. Anyways, as you probably know, ICS and Zero Trust are second only to AI in terms of buzzwordiness. So I thought I'd come and talk to you a little bit about what that means to me. Because I'm seeing a lot of talk about Zero Trust in ICS environments, but no one's really quite sure what that means. I think we can all agree that we do have some challenges. These are some 2022 statistics. In the OT world, like to think of ourselves as backwater little places, right? No visibility, shared credentials, lots of outside connections. We're certainly seeing an uptick in ransomware and segmentation. Some cases good, some cases not so good. But you can see from these statistics that we're not even at the 50% mark on any of these security capabilities in ICS. The top 5 security exposures in ICS today are, of course, the business to ICS connectivity, as well as remote access, the internet, both that you know about and don't know about, segmentation in general, and visibility monitoring, whatever you want to call it. We're starting to see some visibility, and depends on the organization, but the deeper you go, the darker it gets, shall we say. So I thought I'd start by figuring out what Zero Trust really means. Well, if you talk to the firewall vendors, it's Zero Trust network access. It's firewalls and segmentation. If you talk to identity vendors, well, of course, it's all about people and identities. That's what Zero Trust means. So I thought I'd ask ChatGPT, because, why not? Get some AI in with my Zero Trust and my OT. And actually, not a bad answer from ChatGPT. It's the never trust, but always verify. Identity verification is important. And the identity and integrity of users and devices, which is something we have a lot of in ICS environments, is key. So you know what? ChatGPT kind of came through all right there. What does it mean to implement Zero Trust? Well, there's a few approaches to that, right? And unfortunately, what I'm seeing is people implementing Zero Trust based on capabilities of products or capabilities that they have today, and not so much based on their requirements or their desired outcomes, right? I can go buy Zero Trust. Anyone? I'm sure we can solve that problem by buying something. There's lots of guidance, right? Everyone's got their opinions. I want to talk a little bit about maybe how we can wrap our heads around this, though, and get started with Zero Trust. So let's go right to the source, NIST 800-207, right? It's a long document, but the core of Zero Trust, according to NIST, is least privilege per request access decisions in the face of a network viewed as compromised. And, excuse me, one of the words that's missing there is continuous as well. I think it's on this next one. These are the 7 tenets of Zero Trust. I'm not going to go through them all, but it's all about dynamic policy, continuous evaluation of health or trust or whatever you want to call it, founded in actually knowing what you have on your network, because we all do that too, right? That's where we're supposed to start with security. So when we try to do this in ICS, we have some technical challenges. Our cybersecurity maturity is pretty low overall, right? So are we even thinking about Zero Trust? We got, let's start with the basics, is kind of where we're at with cybersecurity in ICS. We don't know what we have, right? At least, we might have some ideas, but when you get down in the weeds, we don't know what we have on our networks. And identity, I think, is the big gaping hole in most ICS networks. We, operator as a username, operator as a password. It goes a long, long way. And then you get to the organizational challenges, right? there's limited appetite and also limited opportunity for change, right? To be fair, like you're pumping whatever, keeping the spice flowing. You don't want to take the time to stop trusting everybody, right? I've been there. You know, you got the guy, I've been here for 40 years and we've been doing it the same way. We've had no problems. Go away. Leave me alone, right? And then templates or best practices, right? Every site is unique. It's one of the things I was talking to a customer and they said, yeah, you know what? We've got 100 facilities. They're all unique. So we lose one, not a big deal. We got 99 other ones. Like it'll take them a while to figure out how to take down the next site, right? So anyways, yeah, we have a few challenges when it comes to implementing Zero Trust. And this is just some of them. There are quite a few others. One of the things or tools that we have is the sliding scale of cybersecurity. So this is stolen from SANS. And we've got architecture on the one end, and we've got offense. I hesitate before saying that because that is not really offense, but it is taking active measures to protect yourself. And in the middle, we've got a bunch of other things, right? Architecture, self-explanatory. We've got passive defense, which is basically going and buying a product, plugging it in, light turns on, that's all you got to do, right? And then active defense, I'll talk about a bit more later, but that's people, you know, that's where the magic happens. Knowing what you have, leveraging your knowledge of your environment to get rid of the attackers. And as we get up to the more mature organizations, we have threat intelligence and, like I said, actively deploying countermeasures. Of course, as you would expect, bang for the buck, you get a lot of it. You get a lot more bang for the buck with architecture, passive defense, and it decreases as we move our way up. So that kind of says we should be starting with architecture, right? And in fact, there are 5 critical controls for ICS. I guess we decided 18 would be too many. So let's start with the basics here, crawl before we run, and start with the 5 critical controls for ICS cybersecurity. And these are incident response, defensible architecture, visibility and monitoring, secure remote access, the Achilles heel of many in an environment, and risk-based vulnerability management. I'm going to talk about these a little bit fairly quickly, although it takes a while to go through them all. But again, this is a white paper that you can go and download that dives into all of these controls in detail and what you need to be thinking about when you're applying them in an ICS environment. And I will talk about that at a high level as well. First one, as I said, bang for the buck. This is my favorite topic, which is a defensible architecture. And this is what the critical controls say. You want to build an architecture that supports all of the other things I'm about to talk to you about, right? Supports the visibility and the logging and the asset identification, segmentation, DMZs, control of communication within the environment, right? If you don't have a defensible architecture, you're stuck. You can't implement any of the other controls. You can't do anything to help yourself unless you have a foundation to build on. So speaking of architecture, high value, low cost, talked about that. Now, I also talked about the rate of change in industrial environments. Let's just say it's not fast. So when we talk about architecture, we're usually talking about where do I want to end up? Where do I want to be? What does good look like? And you know what? I'm ecstatic if I can get a picture of what good looks like and then have an organization that doesn't move further away from that. Every decision you make should not move you further away, ideally should move you closer to that, but it may take a very long time. It's a long game. You're looking for new sites, site upgrades, site refresh. You're not going out and retrofitting architecture in any environment, not to mention ICS environments. And of course, we want to start at the IT/OT internet boundary, right? That is, I mean, I can make up statistics like as well as anyone else, right? 80–90% of ICS attacks come in through that boundary. Sure, people can walk on site, there's wireless, there's lots of other stuff, but that IT/OT internet boundary is where we want to start. So when we talk about secure architecture, We want to understand and document our requirements, right? And there are as much as in any other case, we have cybersecurity requirements, absolutely. But we have business requirements as well, right? We are protecting the money-making engine of the organization. And if we screw that up, well, then we don't have anything left to do, right? We want to inventory. We want to know what we have. Have you ever heard a framework talk about inventory before? Okay, we'll move on. We need to know what we have. And that means, especially in an ICS environment, and especially when we're talking about architecture, that means grouping and labeling everything. And I will talk about that a bit more on the next slide. We definitely want that strong boundary. We want secure remote access. See, this is foundational for all the rest of the controls. We want to segment our networks, and not just IT from OT, but different processes, different types of systems, different functions within the OT network. And especially because it's really hard to get strong endpoint protections in an ICS environment, we need that network visibility monitoring, which leads to response. Endpoint visibility is great. I'll take it all day. I'm just saying it's not that easy to get. This is a version of the Purdue model, right? I wanted to throw this in because I hear lots of people talking about, oh yeah, our architecture is based on the Purdue model. No, it's not. Purdue model is, for lack of a better term, it's a labeling system. It's a way of putting sticky notes on everything so you know how to categorize them, how to group them, how to refer to them. It has nothing, sorry, I shouldn't say that. It is not an architecture. It is a tool that allows you to talk about architecture, right? With the Purdue model, we can say, all of my PLCs, my controllers, let's call that level 1. Let's call all the local supervisory systems that are right next to those, process local supervisory. Let's call that level 2. Regional or site-wide supervisory, let's call that level 3, and so on. It's just putting a label on everything so that then I can say things like, well, you need segmentation between level 2 and level 3, within level 3, between 3 and 4, et cetera, right? So no one implements the Purdue model. It's just a way to refer to things so that we can have an intelligent conversation about architecture and everything else. So key tenets from an architecture point of view, let's keep the internet out of OT. Now, I'm not saying it's completely, if we could operate an environment completely isolated, sure, great. But that is becoming less and less possible these days, right? Heck, almost all of the vendors have apps for phones and tablets and so on. They monitor from the cloud. They want to collect telemetry in the cloud. But we do want to very, very strongly control internet and OT. If you ever wanted to implement a positive enforcement model, deny by default and permit only what you need, this is the place to do it, right? It's not a free-for-all. We certainly want to control it. You should be using your business systems for regular email, internet, and so on. We want those enforcement boundaries, right? Because again, if we create and establish enforcement boundaries, that supports all the rest of the security controls that we want to put in place. So that means unique credentials, not your business credentials, because how secure are those, right? How many times do people get their usernames and passwords stolen on the business side? MFA, of course, to get in. We want secure file transfer. We, again, want to know what is supposed to be talking so that we can block everything else, block everything else and permit what's supposed to be talking. And of course, monitoring and logging that, because again, we don't do a great job of collecting logs from endpoints or getting visibility on endpoints, right? We are kind of stuck on the network. So we need to architect a network that gives us those choke points that enable that kind of visibility. And of course, I always have to hesitate when I say it, but I'm a fan of Active Directory in an ICS environment. It does bring you a lot of centralized control, authentication, policy, and so on. But it's got to be managed by someone other than an engineer, please, and it's got to be completely independent of IT. And of course, we have antivirus, we have patching, we have all of those other infrastructure activities as well that should be managed independently of the business. So those are, I could go on about architecture forever, so I won't, but those are some of the key things that I do talk about. which leads into, so now we've got a defensible architecture that enables us to do monitoring. And again, the control says we want continuous network security monitoring of the ICS environment with protocol-aware tool sets and system of systems interaction analysis capabilities. That's a mouthful. So understanding what's going on your network to inform operations of potential risks to control. There's lots of ways we can do this. Well, not really. We have passive monitoring. That's our go-to. Again, we don't touch anything, we don't interfere with anything, we don't take outages, we just monitor passively, and we can leverage those choke points that we created with our defensible architecture. And it has an added bonus that, hey, maybe we can get close, we can approximate an asset inventory. That's a win. We can group our systems based on their configuration. Labeling anything, anyone, right? We can identify vulnerabilities to a point, and we can certainly improve our logging maturity, right? I am ecstatic if I go into an environment and there are logs somewhere. Even if they're scattered across all the endpoints, hey, I've got something to look like. Like that's a benchmark. Obviously, we'd like to collect them centrally and then build some use cases and alerting and correlation and all of that. But hey, let's have some. So for visibility, what are our requirements? We want a full inventory, at least of IP connected things. Like I get when you get right down to it, to field bus and serial networks and so on, yeah, that's a challenge. But we want to know not only what do we have, but who is talking to who. Because the one big advantage that we have in ICS networks is that they are relatively static, right? They've been doing the same thing for 40 odd years, right? So we can actually, to a point, catalog all of the systems, all of the communications paths. We want to know, we want to have visibility into the actual ICS protocols, right? What commands are being sent? Who's connecting where, especially remotely? We have vendors out the wazoo connecting from who knows where, doing who knows what with who knows what credentials. So again, come back to those choke points. That's where we can get the visibility. That's where we can force the authentication. We can put our passive monitoring. And like I said, I'm happy to have any logs. But there are a lot of Windows systems. I say OT or I say ICS, and people think process control. We have controllers, we have machines, we have automation. And yes, we do. But guess what? It is supported by a ton of Windows. And that Windows stuff is, I can't say it, I can't make a blanket statement, but it's not generally process critical. It's valuable, it's important, we don't want to do without it. But it's not, if you have a Windows system going down, you're not going to be taking out the entire process, unless it's that one system, of course. But we can bring a lot of our traditional Windows management capabilities into the OT environment and benefit, because those are the systems that are also getting compromised and attacked, right? So where can we put visibility in? Well, firewall and network infrastructure logs. That's easy, that's free. You could add NetFlow to that list, right? Every packet or every session that's going through a firewall, we should know what it is. Absolutely, there's lots of vendors, lots of products that do passive network monitoring, which will help us, as I said, with the vulnerabilities, the inventory, the communication partners. Got Windows event logs. If you have centralized authentication, it's something we generally lack and I would like to see a lot more of. That's a great source. Actual logs from OT systems, maybe. As well as the systems that are managing them. There we might get a little bit more traction. Which takes us to our third control, secure remote access. Let's put an end to what I like to call RDP and free. How many of you have those environments where you can RDP, or you come in via remote access, you RDP into something, and that's it. You can do whatever the heck you please. The whole network's your playground at that point, right? Let's please, please, please put an end to that. There's a whole bunch of controls, a whole bunch of ways we can do that better. Again, according to the critical controls, we want to identify and inventory all remote access points, including that hotspot plugged into the back of that server you didn't know you had. We want on-demand access, we want MFA, of course, and this all comes down to some sort of jump host, bastion host, whatever you want to call it, as long as you don't call it Citrix, environment. Sorry, that was out loud, wasn't it? So key components, distinct credentials for OT. Again, your corporate credentials will get compromised, period. It happens all the time. So you should need a separate set of credentials, MFA. Actually, I was watching the latest season of the Grand Tour with my kids this weekend. And long story short, what's his name? Jeremy Clarkson started a separate show where he started a farm, and I actually figured out what a sheep dip was. Because that's where they actually take the sheep. They take a little hand crane, they crank the sheep up, turn it over there, drop them in a vat of some sort of antiseptic, haul them back out, and they're nice and clean. So I never knew where the sheep dip was until I saw that. The visual was very informative there. That's for USB devices, though, or file transfer, not sheep. Yes, this is one of the key points where we can do identity-based zero trust, right? You get onto a jump host, you get access to a jump host based on your identity. Once you're on there, you get access based on your identity, and that host gets access based on its identity, right? We can get lots of auditing, and there are solutions today, and they are getting better, where we can get credential vaulting and recording and sharing and approval workflow and all that kind of stuff as well. I'm going to go through this fairly quickly because I still got a few things to cover. Again, I will share the slides. This is my version of a relatively ideal remote access architecture. First step, terminates in the DMZ. I don't care what credentials you use, but these are not your OT credentials. They get you to a DMZ. That's it. Realistically, all you can talk to is a file transfer solution and a jump host. That's it. Dedicated ICS authentication happens after that. So I shouldn't have combined those, but MFA to get in, then dedicated ICS authentication to actually log into that jump host. So one credential to get into the DMZ, one to get onto the jump host. And as I said, I got this totally out of order, didn't I? Only get access to the jump and file servers. The file servers there, I don't care how you structure it, but some concept of I upload a file, it gets scanned, it gets copied over to this other file server. Once I'm in the environment, I can copy it off that file server and back and forth. And not wide open to anybody and everybody because we don't have any usernames or access control, please. It's great when I can, we're pen testing and it's like, oh, I go to the file share. There's every single project file, every single architecture diagram, every single anything to do with the OT environment. Jump servers authenticate against an ICS Active Directory. Then they, you might have multiple vendors. You have a vendor 1 jump server, vendor 2, vendor 3, vendor 4. And those users only get apps that they're authorized for. And those servers can only talk to the processes that they're there for, right? Multiple levels of control. And then the jump server network, so the jump servers are controlled at the network level as well in terms of what they can get to. When we talk about segmentation and the Purdue model, I want to see segmentation between levels 2 and 3, 3 in the DMZ in level 4, but also within, especially level 3, I've got ICS servers, I've got file servers, I've got Active Directory, I've got jump hosts, I've got SIM and antivirus and patching and all that. All of those should be grouped into separate segments as well. Vulnerability management. I think we all know what vulnerability management is, but risk-based is the key word here. We want to mitigate the impact and monitor for possible exploitation. The thing is, risk-based. So, if I patch a vulnerability in a system that does everything I tell it to do, that will accept any command over the network, that doesn't do any authentication, doesn't do any logging, have I solved the problem? No, I think is the answer to that. Patching things that are insecure by default is a waste of time. We don't have enough time to do all the things we need to do. So that's why we talk about risk-based vulnerability management, the things that could be exploited to gain additional access. We're seeing lots more vulnerabilities, but we're seeing that the advisories don't have accurate information. The vulnerabilities are relatively serious, but only 13% are extremely critical. So again, risk-based. Let's start with the things that really matter. 83% are deep within the network. Yes, I would like to fix those, but it's easier for me at this point to stop people from getting to that point in the network. So that's where I'm going to focus my effort. So start where attackers are most active, right? Level 3, close to the business network, close to the internet, on common operating systems that are familiar to attackers, easier to update for you, right? Again, that Windows stuff, closer to the business network, not as critical for operations, so let's patch it. And do it based on impact to your environment. What are the things you can't afford to lose? Those are the things where you start. There's a couple links there. Crown jewel analysis and consequence-driven cyber-informed engineering are a mouthful, but also really good ways to focus your effort. I'm going to go through this. I'm not going to belabor the vulnerability. Bottom line is prioritize. Have a process. Oops, that's not my pointer, and I can't see it anyways on this screen, so I won't worry about it. But the bottom line here is figure out if it really, 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 really needs to be patched right now, and is that more important than whatever operations you have going on. Otherwise, mitigate it and patch it when you have a chance. There are some that need to be patched now, absolutely. But otherwise, I don't want it sitting forever, but let it wait, patch it when needed. Again, though, stuff like your Active Directory, your jump hosts, your antivirus, all those kinds of utility servers, those aren't process critical. Patch them, keep up with them, because that's where attackers land. And lastly, incident response. You need an operations-informed incident response plan. You can probably leverage more from your real-world emergency management than you can from your IT incident response plan, although they're both relevant, right? And practice, 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 because you will find so much that you didn't think about or didn't consider when a real incident comes along. IR is important regulatorily now. You must report incidents, you must have a plan. There's reputational risk, there's operational risk and financial risk, right? We have a huge dependence on IT systems now, whatever you want to call IT systems, computers. So everyone is a target, right? You drive your car to the mall, someone's pulling on your car door handle, right? You're a target. It's not a matter of if, but when, which means that prevention is ideal, detection, absolutely necessary. But if I run around here screaming, fire, that doesn't help much. We need somebody who's going to come and respond and do something for that, to put that fire out. Active defense, I mentioned it earlier. This is where, this is a very summarized version of it, but you're leveraging your home field advantage. You should know your networks, your environment better than any attacker ever would, and you need to use that knowledge to get an advantage, to get a leg up on the attacker. Use your knowledge of your environment to evict them from your environment. So from an incident response perspective, be able to island your network. I think of incident response in terms of thresholds. If something happens, I've already made a decision to take an action, and I know the impact of that action, I know how I'm going to take that action, and I know both the impact of doing it and of not doing it. For example, isolating IT from OT networks. I know how to do it, I know how to operate in that situation, and I have pre-made the decision about when I'm going to do it based on some thresholds. We want to, they call it minimum viable operations or turtle mode, right? What can I do to isolate myself and still keep operating? Communication is paramount, as is collaboration. Is your IT vendor or OT vendor going to show up to help you? Cisco has famously shown up in 18-wheelers when people have data center fires. Will your OT vendor do that for you, right? So bringing this back to zero trust, because this is kind of the focus here. The critical controls all support zero trust in some way. Incident response, we've got that minimum viable operations to restrict access to enterprise resources. That is one of the tenets of zero trust, right? Restricting access to enterprise, or in this case, OT resources. As a part of incident response, we should understand how we're going to get to that position. Our architecture, of course, as I said, supports network segmentation, supports zero trust network access, supports authentication and identity management, and much, much more. Our visibility and monitoring, again, we need to see everything. That is just straight up matches the requirement from the Zero Trust framework. Secure remote access, same thing, identity-based, only getting access to what you want. And then the risk-based vulnerability management feeds a lot into knowing what you have, into your asset inventory, into your exposure, your integrity, and so on. So how do we do this? Well, let's start with the easy stuff, right? Defensible architecture. Easy things we can do to implement Zero Trust or move towards Zero Trust in an ICS environment. Control communications at the boundary, and then once you've got that problem sorted, segment out your network at the lower levels of the environment as well. And establish those choke points for network monitoring. Right? Those are all relatively easy things to do. Network architecture is not complicated. It's just the time. You have to do it at the right moment in time, right? When you can implement those things. Then if we talk something a little bit more difficult, authentication and authorization of remote users really should be table stakes, right? It shouldn't be that hard. Certainly, if we want to get into an identity-based defensive posture, remote access is where we start with ICS. Push as much of that out from an architectural perspective, and then you can use those jump hosts, use that remote access architecture to authenticate and authorize all your users and control what each of them can do. Get your sheep dip going, right? Secure file transfer, not open for everybody, but so provide a means to upload and download files that are known to be safe. That applies to USB as well as uploading and downloading. And improve your visibility and asset inventory. Getting passive monitoring in place, again, is not that complicated. There will always be work to do to improve it and alert and so on, but getting started is not that hard. So secure remote access and network visibility monitoring, they directly support Zero Trust, and really they are solvable, manageable, even better problems today. Then we got some harder things. Vulnerability management and patching, again, for certain systems really easy, for other systems maybe not so much, but something we need to be working towards. Continuous authentication and authorization, especially of devices. And that's the big elephant in the room when we talk about Zero Trust in OT. How many devices do you have? What is the identity of all of those devices? Well, there is no who, there is no person, there's no one logging into them necessarily. But those devices are your critical devices on your network. And doing continuous validation and authentication and authorization of device-to-device communication. There are starting to become solutions both product-wise and architecturally for that, but it's tough. And so is active defense. I've worked with a $4 billion company that had an engineer spending 50% of his time running all of IT for OT for that organization. So getting people to do things is, they may want to, but that's no mean feat. So here's what I get told. Reasons you can't improve ICS cybersecurity. Can't take an outage. Yeah, we hear that. Time and people constraints. Different priorities. The potential of an impact either during a change or as a result of a change. Ancient hardware and software. Interdependencies between all of that. Lack of vendor, meaning the OT vendors, buy-in. So we got lots of excuses built in. But let's look at how we can do this. A gradual approach is okay. This is, especially in OT, it's a long game, right? We want to know where our destination and just try and crawl towards it. Architecture's free, right? You don't have to pay anything for that. Virtualization gives us a lot of advantages in an ICS context. Vendors are, vendors, to be honest, if you're buying new OT products from vendors, they've got security capabilities. You just got to work a little bit to get the security guy in the room during the planning phases, because you don't get it if you don't ask for it. Start with your new initiatives, your new sites, your site refreshes, where you can get as close to greenfield as you can. C-suite certainly has visibility. That is helping our cause. And we can start with the boundary, let's not start with the process. Leave the process alone. There's a ton of work to be done at that IT-OT boundary with those Windows systems. And of course, monitoring isn't disruptive, so why not? It does take some people time, but monitoring is something we can do that isn't disruptive. So there are lots of reasons that we can improve ICS security, cybersecurity. Most important thing, start. Do something. I've heard for too long that this is too difficult of a problem, right? It's all those no reasons that we can't do anything. Well, there's lots we can do. Zero trust isn't magic. It's not a product. It's not a thing. I don't even know that I don't even know what it is. It's not a thought process. It's not a journey. It's just a bunch of concepts that can help us improve the overall security of our environments. And there's lots of things we can do to inch closer to that ideal. So that is the short version. Like I said, there's lots of content there. I will share these slides. There's some extra slides at the back end too. So they will be, I'll make them available however that happens. Worst case, hit me up on LinkedIn or something like that. And otherwise, I think I got a couple of minutes for questions if anyone has any. Yeah.
Yeah, I just had a question. Just around IT/OT convergence, big buzzword, obviously in industry for a little while now. Just wanted to get your thoughts maybe on IT/OT convergence and maybe do's and don'ts, or if you had any recommendations on where to start, if those align to these domains that you were talking about, or any priorities there.
Well, I'll start by saying I hate that term, IT/OT convergence. But we are seeing a lot of cloud, obviously, even in OT. And we like to look at cloud. The best solution we've got today is think of cloud as yet another process. So isolate it from all your other processes, put it over here, give it controlled access to the internet and so on. I would argue that sure, there's some IoT type stuff in our IT environments, your video cameras and meeting room things and all of that. But IT and OT convergence is not something that we really, what it sounds like is not something we want. We want to keep our OT environment separate. We have a lot of IT stuff in OT, and that's where we are seeing a lot of that convergence, and that's where we see a lot of the opportunity, because again, all of that IT stuff is stuff that we can secure, shall we say, without direct impact on the operational side. So that's my 2-second version, but I really hate that because we're not converging IT and OT. We're getting more IT in OT, but that's my 2 cents. I think we got one more over here. Okay, I'll tell you what, I'll come over and talk to you because we've got to move on to the next presentation here. And thanks very much, everyone.